Okay, so moving into Module 14, we are going to be working with polynomials. So Section 1 is just understanding what a polynomial is and how to work with them. So a monomial is a type of polynomial, and it is just a number, a variable, or a product of numbers and variables that have whole number exponents. So no fraction exponents. A monomial can't have more than one term, and it can't have a variable in its denominator. So it's just one piece. There's no adding and subtracting. So in the chart below, in the monomials, 5 is a monomial. It's one piece. X is a monomial. It's just one thing. Negative 7xy, it's all multiplication, so that is still a monomial as well. And then 0.2g squared, same thing. It's got a whole number exponent and a number times a variable. So no adding and subtracting involved. Moving over to not a monomial, we have negative 3 as an exponent in that first one. We can't have a negative exponent. It's got to be a whole number. And then the second one, 7y minus h, that's two chunks. That's two terms. That's not a monomial. We only want one. And then 3 over c, we can't have a variable in a denominator, so that is not a monomial as well. So example 1, just determine if the given term is a monomial. So this is 3 times b times c. That's a yes. There's nothing odd there. X to the third power, it's a whole number exponent. So yes, that one is as well. Next is the square root of z. That is a no. Ooh, I'm on shapes and not writing. That is a no. We can't take the square root of anything. And then d 6 over r, that's a no as well. We can't have a variable in the denominator. And then we have 8r plus 2. That's a no as well. That has two pieces, two terms. We need just one term. So now to classify polynomials, we need to have a few more vocab words here. And a polynomial is a monomial or the sum of more than one monomial. So we can have more things added or subtracted together. So a monomial has one term, a binomial has two terms, and a trinomial has three terms. The degree of the polynomial is the greatest sum of the exponents of the variables in each term. So we have to add the exponents of each variable in each term, and then the one with the largest number is the degree of that polynomial. And we'll do an example. I'll show you exactly what that means. Standard form is when we rewrite the polynomial with the highest degree first, all the way down to the lowest degree. The coefficient is the number being multiplied by the variable, so that number out front. And then the leading coefficient is the coefficient of the first term once it's in standard form. So for example 2, we have to write it in standard form and then classify it by its degree and number of terms. So what I mean by the degree here, this one has two terms. So right now I have a and b squared for variables in the first term. That a doesn't have an exponent, so it's really a 1. So we add those together. The degree of that term is a 3. Over here, same thing. B is a 1, so 2 plus 1 is a 3. So the degree of both of these is a 3. So we can leave it like this for standard form. And then the leading coefficient in this case is 8. That's the leading coefficient. The degree is 3. And then it says to classify it by its number of terms and its degree. So the degree is 3, so we're going to say this is a third degree binomial because it has two pieces, two terms. So third degree binomial, and the leading coefficient is 8. For this one, we have to find the degree of each one. So the x is a 1, so that would be a 3. This is going to be a 4, and each of one of these is a 1, so that's a 2. So the largest one is the 4, so it's going to go first for standard form. It's positive. Then the 3 would go next, so plus, it's positive, so plus 4xy squared, and then the 2 is the lowest, so plus 5xy. So the leading coefficient here is 3, and it has, the degree is 4, so this is a 4th degree. It has 3 terms, so trinomial. And now, to simplify polynomials, we combine like terms. And like terms have the same variables and the same powers, so the same exponent. So we have to go through and find the one with the largest exponents. So the degree of the first one is a 3. Then we have a 3. This is a 0 because it doesn't have any variables. This is a 3. This is a 3. And 2 to the 5th power is 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So this is actually a 32. And that has a degree of 0 as well because it does not have any variables. So now, since all of the ones with variables have a degree of 3, it doesn't matter which one goes first. So I'm going to go all to the r to the 3rd power. So I have 5r to the 3rd power minus 1r to the 3rd power. So that would leave me with 4r to the 3rd power. Then I have, let's change color. I have negative r squared s, and I have negative 3r squared s. So negative 1 and negative 3 make negative 4r squared s's. And then lastly, I have a positive 6 and a positive 32 that would turn into a positive 38 when we combine them. So that is our simplified answer here. And then this one, this has a degree of 2, this is 2, this is 0, 2, 2, and 0. 5 to the 3rd power is 5 times 5 is 25 times 5 is 125. So now let's go through and put like terms together. So 7a squared goes with 1a squared. That would make 8a squareds. Then I have negative ab goes with negative 5ab. So that would make negative 6ab's. And then last, I have a negative 75 and a positive 125. So that would leave me with a positive 50. So simplified version is 8 squared minus 6ab plus 50. And our leading coefficient is 8. It's a 2nd degree and it has 3 terms, so it's a trinomial.